My wonderful chemistry students. I noticed that quite a few of you, with this being the day before break, did not make it to class, and we absolutely still had chemistry that we had to cover. So I just want to take a quick moment to make a video for those of you that couldn't be here with us, talking through the concepts and then showing you the assignment that we worked on today. So the first important thing we did is we quickly reviewed what we learned last time, which was looking at the periodic table and identifying what kind of ion and charge an atom would form. So when looking at this, we first have to know that, yes, we have metalloids here, but generally to the left of our staircase are our metals, and to the right are the non-metals. Metals lose electrons and non-metals gain electrons. So if I was looking at anything in group 1, hydrogen is a non-metal, but the rest of us are metals. So let's say potassium. Potassium is a metal. Metals tend to lose electrons. And because we were in group 1, we know that potassium has one valence electron. And so if we have one valence electron and the atom loses that valence electron, then we're going to form an ion with a positive 1 charge. Okay? So group 1 metals, that's what they tend to form. Group 2 metals, similar. We know metals lose electrons, and that if we have calcium, calcium has 2 valence electrons. If we lose those 2 valence electrons, then we'd get a 2+ ion, okay, with a +2 charge. Our transition metals, we'll address that here in just a moment, but the transition metals, we have a lot of them that occur naturally with more than 1 charged ion. And so in the name, we have to give the charge. Like iron, we see iron 2 and iron 3. And so I have to tell you if it's an iron 2 or an iron 3, and we would do that with Roman numerals in the name. Now, aluminum. This is a common one. Aluminum is a metal. It is a group 13 metal, so that means it has 3 valence electrons. And metals lose electrons, so it will lose those 3 valence electrons, and aluminum will form an ion with a 3+ charge. Okay. On to our nonmetals. Nonmetals tend to gain electrons, and so if we were looking at nitrogen, nitrogen is a nonmetal. It's in group 15, it has 5 valence electrons, but we're trying to achieve that octet by either losing or gaining. So if we are going to gain electrons, we'd want to gain 3 more so that we could add that to our 5 valence to have a total of 8. So if we have a non-metal in group 15, it tends to form an ion with a -3 or, -3 charge. Non-metals in group 16, our nonmetals in 16 have 6 valence electrons, so they would gain 2 more to get to 8, so we'd get a 2-, and then 17, 7 valence electrons. Nonmetals gain, we'd gain 1 more, so we'd have a -1 charge. We use these charges when we are looking at the formula. So if I have an ionic compound between potassium and iodine. Okay. So if I have an ionic compound between potassium and iodine, I know that the symbol for potassium is K and iodine is I. And then I'd go to my periodic table and I'd go, oh, potassium's a group 1 metal, so it's going to have a +1 charge. Iodine's a group 17 non-metal, so it's going to have a -1. We can then use the crisscross method to determine what the formula is. So that's when you take the magnitude of the number for the charge, and then we make it the subscript of the other ion. So meaning potassium was a +1 and iodine was a -1. So I would take the 1 from the potassium and make it the subscript of the iodine, and the 1 from the iodine and make it the subscript of the potassium. And when we have the subscripts of 1, then we don't write that down. If we can, we're going to reduce this down to the lowest possible whole number ratio, but 1 to 1 is the lowest it can be. So the formula for an ionic compound between potassium and iodine would be 1 potassium and 1 iodine. The name that we would give, we say the cation, and then the anion we end with "ide," so it'd be potassium iodide. Okay. Onto a magnesium and oxygen. So our symbols are Mg and O. Magnesium is a group 2 metal. So magnesium would give us the 2+ charge. Oxygen is a group 16 nonmetal, so we would get a 2-. And so we're going to take those charges and the magnitude of those charges and crisscross for the subscript. So since magnesium is a 2+, our oxygen will have a subscript of 2. And since the oxygen is a 2-, our magnesium will have a subscript of 2. But this is a good example where we can reduce this down. This is not the smallest whole number ratio. So we could divide both of them by 2. It could be reduced down to a 1 to 1 ratio. So that's where our formula would end. We'd have 1 magnesium and 1 oxygen. And the name of this ionic compound would be magnesium oxide. Okay. Our aluminum and bromine and the cesium and the nitrogen, you should hit pause and try these on your own and then come back and see how you did. We talked about aluminum. We recognized that it was a metal in group 13, and so that would result in a 3+. Bromine is a nonmetal in group 17, so it has a -1 charge. So when we crisscross the magnitude of the charges for the subscript, the 3+ in the aluminum, that 3 will become the subscript of the bromine, and then the 1-, the 1 from the bromine, would become the subscript of the aluminum. A 1 to 3 ratio is our lowest whole number ratio. So that's what our formula would look like. So it would be aluminum bromide. Cesium is a group 1 metal, so we get a +1 charge. Nitrogen is a group 15 nonmetal, so it has 5 valence electrons, and we'd gain 3 more to get to 8. So we'd have a 3-. So then when I crisscross, it'd be a cesium 3, nitrogen 1. Again, that's my lowest whole number ratio, and so that would be my formula. And the name would be cesium nitride. Okay. When we have transition metals, okay, so transition metals, like we said, a lot of these transition metals, they have more than one ion that they form in nature. For that reason, when it comes to transition metals, so here are our transition metals, we have to say what their charge is in the name. So if I was referring to iron with a 2+, in the name I'd have Roman numeral 2. But if it was an iron 3+, then I'd need my Roman numeral 3. Okay. There are 3 transition metals that we do not say their name, and we do need to recognize and know their charges. So aluminum, like we discussed at the beginning of the video, is a 3+ because it's a metal in group 13. And if it has 3 valence electrons, and metals lose electrons, so if we lose those 3 valence negative electrons, we get a 3+ charge. And then just go diagonally from there. So aluminum is a 3+, zinc is a 2+, silver is a 1+, and we need to know those 3 transition metals. We will not say those charges in the name. So silver and sulfur. Silver, like we just said, oh, that's one of the 3 that we need to know the charge, and silver has a +1 charge. Sulfur is in group 16. So it's a group 16 nonmetal, so we'd have a 2-. And so it would be silver, 2, and then 1 sulfur. That's the lowest ratio between them. Silver sulfide. All right, let's look at the tin. So tin has a symbol of SN, and then fluorine is a capital F. Tin is a transition metal. So metals lose electrons, so we know it's going to be a positive cation, but its location doesn't tell us the charge. The Roman numerals do. So since this is a tin 4, that means the charge is a 4+. And then fluorine is a group 17 nonmetal, and so we have a -1 charge. So we will take the 1 from the charge in the fluorine, that's a subscript of the tin, and then the 4 from the charge of the tin and make it the subscript of the fluorine. And so that would be our formula. Something important I want to point out. When we say the name, it's not just tin fluoride, we have to say the charge. So it would be tin 4 fluoride. But notice there's not 4 tin atoms, okay? So the 4 in the name, tin 4, stands for the charge of that tin atom. So it'd be, this is the formula for a tin 4 fluoride. Okay, like before, hit pause, finish the rest of these, and then come back and see how you did. Magnesium chloride. Magnesium is not a transition metal, so we don't have to say it in the name. So we have a magnesium chloride. Aluminum is a transition metal, but it's one of the 3 that we need to remember what their charge is. Let's see. So aluminum is a 3+, oxygen is a 2-. So I'll take the 3 from the aluminum and make it the subscript for the oxygen, and the 2 from the oxygen and make it the subscript for the aluminum. Okay. Notice that it's electrostatically neutral. That if I have 2 aluminum ions that each have a +3 charge, and those are ionically bonded to 3 oxygen ions, oxides, then we would have, they each have a -2 charge. And so we have this +6 canceling with this -6, so that it's electrostatically neutral. Iron and oxygen. Iron 2+. I only know that because it's in the name. Okay, I know it's a metal, I know it's going to be a cation that loses, and the 2 tells me the charge. And then oxygen, a nonmetal, group 16. So then I would crisscross the charges for the subscript, but this is again an example where we can reduce down. So that'd be our iron 2 oxide. Okay, so that was us very quickly talking through this. We then went on to the assignment in the back of the packet. Okay. And we completed all of these. Okay, so like sorry, 1, 2, 4, these ones. Okay, so we completed those and we filled those in, and then also these ones. Okay. And then we were able to do this entire table. Let me start. So we were able to complete this whole table. And then the last thing we did was this last middle section of the assignment there. Okay, so that's what you need to have completed before next class. If you have any questions at all, please feel free to send me an email. There's going to be times where I'm going to be out of service range over break, and so I will get back to you as soon as I can. It should be well before January 4th. But that would be the absolute latest. But I should be able to reply to you before then. Okay, thank you guys for your hard work.